Hello guys, as promised, in this video, we will go through some interesting materials that are not too much related to the learning of this course. So if you found them to be boring or too difficult to interpret, you can simply skip this video. But I do hope that you found this video to be interesting. The first example here, example 2, is not new. We already did something similar in example 1.2, right? So here, let's take a look again. Here, I give you two options. The first option is to deposit $100 for 2 years, and by the end, you will be getting $110. Let me get the pen. So in the end, you will be getting $110. In the second option, you deposit for 1 year and then withdraw and make another deposit for the second year. It's easy to do the computation, and in the end, the amount you will receive is $110 plus 25 cents. So the second strategy actually gives you 25 cents more than the first strategy, okay? So if you are rational, you should go with strategy 2, right? So we can take this example even further. So assume that you can deposit for half a year, okay? So because in total, we are talking about 2 years. So here is 0, here's 1, here's 2. So suppose that you deposit for half a year, okay? Withdraw, deposit again for another half a year. So every half a year you withdraw and make another deposit. So in total, you are going to do the deposit 4 times, okay? And then you calculate what is your AV2 at the end, okay? Is it bigger than 110 plus 25 cents? Okay, check that. Okay, what would you conclude by doing this example and the half year deposit example? Right. So then that assuming this is the case, okay, please check. Then the best strategy for you to do is to withdraw as frequently as possible, right? Because according to this example, the worst case is you make the deposit for the entire 2 years, right? And then the second worst is to, not second worst, then the slightly better option is to make the deposit for 1 year and then do 2 deposits, okay? And even better is to do a deposit for only 6 months, but you need to go to the bank 4 times, right? And then you can take to another level. What if I deposit for only 1 month, and then I will need to do 24 deposits over 2 years, right? So each time I will be able to getting more money, okay? Of course, assume that I don't care about gas, or I don't care about walking to the bank, okay? Under that assumption, it's actually better for me, okay, to go to bank every day, every minute, every hour, right? If that's possible, and because I'm going to get more money out of it. So here we have a paradox, because this is not practical, right? For banks to allow this thing to happen. So behind this paradox is the inconsistency, which is formulated in the light gray area. In this area, I say let AVT be the accumulated value per unit. So we can set X to be 1 at a simple annual interest rate I, then we have this result, okay? Let's analyze this result together. So let's draw a timeline, okay? This is always helpful in this course. So the final time is t plus s, okay? The first thing I can do is on the right-hand side is I can deposit for the entire t plus s. Let's say t plus s years, okay? Then my value will be 1 plus t plus s times I, okay? This is how we calculate the simple interest rate, right? So here we have a simple interest rate. But I also have many choices. Let's say I want to do 2 deposits, okay, just the 2. Pick any time in between. Let's say I pick T. This is my first deposit. This is my second deposit, okay? So for the first deposit, at the end, I will be getting how much? 1 plus Ti, right? And then I do another deposit. I put this amount into the same account with the same interest rate. I will be getting, so this is my new X, okay? Now, the second deposit is only for S years. So this is how I calculate the accumulated value by the end of time S. So this is, well, obviously this is AVT times AVS. Let's distribute, or let's break this modification. We will be getting 1 plus T plus S times I, and we have one more term that is TS times I squared. So it's very easy to see. Left-hand side has one extra term, which is always positive. So we know this is always greater than right-hand side, which means the second strategy, the strategy given by the left-hand side is better, right? So we have a winner. The winner is always do more than less, right? On the right-hand side, you do 1 deposit. On the left-hand side, you do 2 deposits. If this is the case, right, you can further break the first deposit into another 2, break the second also into another 2, and so on, right? And if this is indeed the case, well, then we have an issue, right? Of course, there are different ways to avoid this. One possible solution is to offer interest rates, different interest rates. So here we have only one interest rate I. No matter how long you deposit for, you get the same interest rate. But obviously that is not the case in practice, right? In practice, banks prefer longer term deposits over short ones. That is why banks offer higher interest rates if you deposit for a longer term, right? So that is one possible way to counter this result, okay? Of course, if I earn more interest rate, so let's hypothetically speaking, let's say for this is not I, okay? I may change this to a different one. So let's try a different color. If I deposit for the entire term, I get higher interest rate. So let's say I put I plus something extra. Let's say J. Okay, J will be a lot smaller than I, of course. So now let's expand. So now this term and this term, then we don't know which one is bigger, right? Then we need to discuss. If J is bigger enough, I will probably prefer the first option, right? The option of doing a longer deposit, right? So that's why this is how bank introduces, why they introduce higher rates for longer term, right? That is to demotivate you to do frequent deposits, but over a short period. Okay, that is very bad for banks. Next is decreasing impatience. I believe this is not an undergraduate topic. This is nowadays we call behavioral economics and finance. So behavioral economics or behavioral finance actually study how human psychology affects different decisions in economics and finance. Okay, we use this example to demonstrate a rather important concept. Okay, here let's do this example. Okay, this is a wonderful opportunity for you. I'm offering you something for free. Here you have two scenarios. Let's look at the first scenario. In the first scenario, I offer you two opportunities. Opportunity A, you receive $1,000 today. Opportunity B, you will receive 1,010 extra dollars in 1 week. So the difference between A and B is that, are you willing to wait one entire week just for 10 more dollars? Right. So that is a question, right? So according to many experimental studies, or actually economists, they hire volunteers to do those surveys. Okay, they are like a monetary incentives. I give you like a $5 to do the survey. According to a lot of studies, most participants choose A over B. Okay, if you feel B is your choice, I could increase the amount. Right, so is let's say A is 1 million today. Option B is you receive 10 more dollars. Okay, but you have to wait another week. Will you wait for an entire week for just the $10 over 1 million? Probably not, right? So anyway, this is the result for scenario A, scenario 1. Now let's take a look at scenario 2. Again, you have, here I have a typo. Here's A. So again, you have two options. Option A, you receive $1,000 in 1 year. Okay, so it's 1 year from now. Option B, you receive 10 more dollars, but wait another week. And surprisingly, okay, for the same participants, most of them choose B over A. Now we have an issue, or now we have a paradox. Now we have something truly interesting that the interest rates we are going to study in this course will never be able to explain. That's why I call this, those slides extra, those slides unrelated to the course, because it's too advanced. So here, what is the difference here? I mean, it's almost like the same option, except, between scenario 1 and scenario 2, we move the timeline 1 year ahead, right? So for scenario 1, so if I draw, here's 10 days. Okay, you have option A is 1,000. Okay, option B is 1,000 plus extra $10. Okay, most people choose to receive 1,000 now. Okay, the same, not 10 days, 1 week. Okay, the same. Let's move everything forward by 1 year. So now the current time, the move. Okay, the same, 1 year plus 1 week. Everything is the same. But the answer goes to the second one. So why? So in order to interpret this observed behavior, economists, they created a concept called decreasing impatience. Right? They really like a double negative. Right? You can call this increasing patience. Right? So if that is more comfortable to you, that means we tend to be more patient in future times rather than now, right? So in terms of future, we are willing to wait for 1 more week to just get more 10 more dollars, right? But we are so impatient at the present time. So that's why, we have this concept called decreasing impatience, right? This is obviously something quite different to our traditional ways of interest. To see this, we can take a look at whether we can apply simple interest to understand decreasing impatience. Okay, so for simplicity, I let the current 1 year interest rate to be I0, the future 1 year interest rate to be I1. Here is already generalized, right? Because in most time we just have one interest rate, I0 equals I1. Okay, now we assume they may be different. So now let's apply here. This is the mathematical result for the first scenario, okay? So in order to do the comparison, we need to compare them at the same time, So this is in 1 week. So I'm going to apply the accumulation formula to accumulate $1,000 to the next week, okay? So that's why I apply time 1 week over 52. There are 52 weeks in 1 year. Right. So that's how I convert 1 week into the unit of years. Then since most participants, they prefer to receive 1,000 now, that means the left-hand side should be greater than 1,010, right? Because people prefer the left-hand side. We prefer more rather than less, okay? But if you apply the same to the second scenario, we get this result, right? Because more people prefer 1,000 plus 10 extra dollars, right? Over 1,000 in 1 year. This is how I accumulate. This is in 1 year plus 1 week, okay? This is in 1 year. In order to match them at the same time, I need to times by the corresponding interest, right? To accumulate to 1 year plus 1 week, okay? So from those two results, we easily see that the current 1 year interest rate should be greater than the interest rate in 1 year, okay? Which is often not the case, okay? To see this, so assume annual interest rate is 2% for 1 year deposit and 3% for 2 year deposit, okay? Here I already add the incentive that longer deposits will get higher interest rate, okay? So now, if there is no arbitrage, meaning if people are indifferent between deposit for 2 years, right, at 3%. Here is you deposit for 1 year at 2%, and then you withdraw the money and deposit again for another year at the interest rate of I1. When we do this calculation, we get I1 is about 4%. It's bigger than the current interest rate, 2%. So that's why I call it. This is often not the case. Soon, actually, in the next subject, we will study compound interest rate. And also continuous interest rate. Neither of them can explain decreasing impatience. That's why I mentioned slightly earlier on that decreasing impatience cannot be explained by anything we learn in this course. In other words, what we learn in this course is too simple to explain what's really going on in our daily life. Okay, that is because this is very easy to understand. If you, let's say, we will learn that this is the formula for continuous interest rate, right? So AV, keep this in mind. We have AV formula in this way. Okay, then what is AVT times AVS is E to RT times E to RS. This is equal to E to R times T plus S. So this is not what we observe. What we observe you know, it's this way, right? Inconsistency. But if we apply continuous interest rate, they should be independent. They should be indifferent. I don't mind whether getting 1,000. I mean, this should be consistent, right? So if I prefer to receive 1,000 now over $1,010 in 1 week, I will keep the same option. I will keep the same choice, no matter it is from now to next week or from 1 year to 1 year plus 1 week. Okay, because according to this, it doesn't matter. Right? The same for the compound interest rate, because if you apply compound interest rate, you also have the same identity. We don't need identity because identity is not able to help us understand why in the first scenario is greater than, but in the second is less than. In using both, people should make the same choice. Okay, there will not be different choice. That is why this is very, very interesting. That motivates economists and mathematicians to propose interest rates that are not continuous, not compound type. They are very, very complicated type. Okay, to simply explain why we human beings, you know, behave so differently from the continuous interest rate. Okay, I will end here. In the next video, we will talk about compound interest rate and continuous interest rate.